again, if you didn't hear me say it before or weren't quite paying attention at that point, we want this to look like y equals mx plus b. So it's been a little while since we've done some graphing, so maybe you forgot about that. That means we want to get that y alone, so we want to get rid of that 2. And 2 is doing what to y? Right now, what's the 2 doing to the y? Math. Multiplying. So instead, we're going to divide. So we're going to get rid of this 2 by dividing by 2. But that means I have to divide these 2 as well by 2. Now, I would not suggest putting this into your calculator or figuring this out as a decimal. I would leave it as a fraction if it doesn't simplify. So 3x over 2, I'm going to leave it as 3 over 2x. And I'll remind you guys of why we like that. And then I have a negative 6 over 2, which is just negative 3. Now, the reason I like this is my m, and this is my b. And remember, b is where we begin on the y-axis, and the m is how we move using the slope, which is rise over run. So hopefully this is kind of coming back to you a little bit. It's been a little while. So we'll graph this. So we're going to begin on the y-axis at negative 3. So this is our beginning spot, is negative 3. We'll put a dot there. Let me make a little bit bigger dot. Put a dot there. And then I'm going to use my slope, which is 3 over 2, to move. So from that spot, so off the y-axis, we always start on the y-axis, we're going to move up 3 and over 2. Up 3 and over 2. Keep doing that. And then remember, we can also go down 3, back 2. So we can also go that way. Then once I have that drawn, we can graph this line. And so there's our line that we wanted to graph in this case. So graphing again, we talked about that a few chapters ago. Coming back now, really important that we know how to graph correctly. Because what we're going to do today is we're actually going to put 2 graphs on the same graph paper. And so if one of them's wrong, obviously there's going to be other stuff going wrong with our graph if the one's in the wrong spot or both of them are in the wrong spot. So we want to be careful about that. So we're going to talk about a system of equations today. And a system of equations is probably something that doesn't seem like something you would know what that, obviously you know what an equation is, but a system of equations is basically a group of equations. We're going to work with just 2 equations though. So it's going to be 2 equations with 2 variables. Typically those variables are going to be x and y. So when we go to look for those solutions for this system of equations, it's what the 2 equations have in common. It's where they're exactly the same. So it's like basically their middle ground. So it's the x and y they have in common. We're going to find solutions today, and that's going to be the x and y that they have in common. So today we're going to use graphing. Tomorrow we're going to learn a new method. Wednesday we'll learn a different method. So we're going to learn different ways to solve systems. And I want you guys to get comfortable with all the different ways so you can kind of make a good decision on which one you kind of like best. You will have to show me all the different methods on a test, but it's just trying to give you guys kind of that exposure to all the different ways that you guys can do this. So we're talking about the graphs. Again, I said we're going to graph two lines on the same graph. So these are supposed to be little coordinate grids here. So I'm going to draw two lines on this graph. Where do you think the solutions would be for this? Where do you think I'd find the solutions? Just in general on these two green lines, where do you think the solutions would be? If you look back to what I said, the solutions are what they have in common. Where would that spot be? Any thoughts? So where the solution's going to be is where they intersect. It's where the two lines come together. That's what they have in common. Like you hear people talk about that, let's come together and agree on something, and it's kind of where they agree. It's where they have exactly the same solution. So the solution is at the intersection. Oops, if I could spell. So where they meet, so that's going to be an x and y coordinate. So at the intersection. Now that's what's going to happen most often. These next two are going to be special cases. So we've talked about what happens when we have no solution or many solutions in regular equations. These two are considered like special cases. They won't come up as often. Anyone have a guess on what kind of lines would give me no solution then? Based off the fact that these two lines have the solution at their intersection. Yeah, they're going to be parallel lines. So lines that are parallel are going to have no solution. So let's show that. So if two lines are parallel, that means they have no solution because they never touch. No solution, so the zero with a line through, you can say, so if I go to graph and my lines are completely parallel, remember parallel means they'd have the same slope, that would tell us that those lines would have no solution. They run alongside of each other, but they never meet. Now many solutions is kind of a weird one. Anyone have an idea what that would? Very good. They're going to be the exact same line, actually. So if I go to graph it and I'm like, wait, I'm graphing on the exact same lines, that means they just keep intersecting over and over again. So like if this is my line and then I go to graph it and then I get the same line that just runs over the top of it, they just keep intersecting. They're exactly the same. So the same line. So all points on that line would work. So we'd say many solutions or infinitely many solutions. So all the points on that line would work. So we could kind of keep graphing all these little points. Any of those points would work. So again, those two are special cases. Those aren't going to come up as often. All right, we're actually going to skip example 1. We're going to go to example 2. We'll come back to example 1 in a second here. Because we're going to do examples 2 and 3, and then I have like an in-class like worksheet with a dad joke for you, because you guys all love my dorky math dad jokes. So, but it's still, you know, there's math involved, so that's, even if you don't like my dad joke, you can. All right, so we're going to solve this by graphing. So again, we're going to look for the intersection of these two lines. So I'm going to try and graph each line and then look at their intersection. Now the first equation is really nice because that's already set up in slope-intercept form for me. So you don't have to show all these steps, but just in case, because we're a little bit rusty with slope-intercept form, where would this equation begin? What's my B? Where would this one begin? -7. So this one begins at -7, that's my B. But what's my slope here? What's in front of, yeah, it's a 1. That's what's in front of my x. So 1 over 1. So I'm going to go to put this line on my graph. So I'm going to begin at -7 and then do my slope of 1 over 1. Now, I would suggest in this case to actually do as many dots as you guys can fit on your graph. The reason for that is because we want to figure out exactly where these lines cross. And so I want to make sure they cross at a particular point. The ones I'm going to give you are always going to cross at a nice coordinate point. They can cross at a decimal, but I try to avoid those as homework, because those are really hard to tell where they cross. So there's our graph for our line. Okay? Now our next equation is more like our warm-up question, where we have to get this in slope-intercept form first. So what are we going to do? Get that y alone. Divide by 4. Very good. Divide everything by 4. Now careful, that -x over 4, I'm going to call that like a -1x over 4. So I'm going, my slope is a -1 over 4, which again, I like slope as a fraction. It makes it pretty easy to work with. My 8 over 4 is just 2, or -2. So my b in this case is -2. My slope is a -1 over 4. All right, so this time I'm going to start at -2. But now I'm going to go down 1 and over 4. So this should get a downhill slope. So think about slope, dude, going nice negative, downhill. Down 1 and over 4, and actually I'm going to hit the other line already. Down 1 over 4. So once I figured out where they cross already, I don't have to kind of keep graphing. I can just draw this line. Careful there. So down 1 over 4. Now I'm almost done. Last thing I need to do with this is I need to talk about where the solution is, and that's where they cross. So I have to look and see where is that point they cross, because that's the x and y we're looking for. So it's over 4 and down 3. So this would be our solution for this equation, where this is my x and this is my y. That's the value that would work in both equations. So if you guys check that, that would work in both of our equations up there. So now for your homework tonight, just being aware that you do have to show me your graphs, and then you have to tell me what the solutions are. So if you just come tomorrow with a whole bunch of solutions, I'll say where are your graphs. And then if you just come with a bunch of graphs, I'll probably ask you what the solutions are. So you need both pieces. You don't need a ton of extra work if you are good at graphing and be able to figure those out in your head. But I'm looking for those graphs to cross. All right. questions there? Let's do one more together, and like I said, then you guys will work on little worksheet together in like small groups here. Okay, so this first one is actually already in slope-intercept form for us. It's y equals negative 5x. Now careful, what's our b in this case? B is 0, there is no b. So this one's going to start at the origin, and then my slope is a negative 5 over 1. So I know I have to have a pretty steep downhill slope. So this time we're starting at the origin. And then I'm going to go down 5 and over 1. And then I'm also going to go up 5 and back 1. I'm going to do that again. I can keep going down as well, but not to move the board around too much. So there's our first line. And so, again, if you're noticing, being really precise about our graphs is going to be really important, because we want to make sure they're crossing a particular point. It's not going to be like an in-between spot where it's not exactly at a coordinate point. It's always going to end up being like this when we're doing these. As you get more difficult, they might cross at non-coordinate points, but probably not an algebra 1. So this next one, I need to get the y alone. So I'm going to move the x over first. So I'm going to subtract that x. And I'm going to write it as the x first, and then plus whatever we had there. But now I have to divide by 2. So my slope here is the number in front of that x, so it's a negative 1/2, kind of like the last one we just did. And then this is going to be plus 9. So my b in this case is going to end up being 9. So b is 9. And then my slope is that negative 1/2. So I'm going to begin at positive 9. So up here. Begin at positive 9. And then I'm going to go down 1 and over 2. Now, sometimes you can be a little bit smart about this and say, well, down 1 over 2, I can already tell I'm never going to run into my orange line there. So I'm going to reverse it. So I'm going to go up 1 and back 2, and there's where we run into that orange line. So you do have to go kind of both directions to make sure you can check that. Once you hit the lines, I don't need you to like show me every dot after that point. I just need to know where they cross. So the solution is where they cross. So in this case, and remember with coordinate points, it's a little confusing. You have to write the x first. So I go right 2 and then up 10. Negative 2, 10 would be the solution. There's my x and y. So we're going to stop for a little bit on notes here. And you guys are going to work on this worksheet. And you can work on it kind of together. You can separate the problems. There's 8 total problems. So I will warn you guys, the bottom row is tougher than the top row. So it might be better to just slice the paper basically in half and give half and half. I'm okay with groups of 3 at the most, just because there might be an odd number. Oh, these are weirdly staped or hole punched. That's not very good. Okay, anyway, if you want a hole punch to put in your binder, you can, but I guess it's not the end of the world. But So groups of 3 would be the maximum, otherwise groups of 2, or you're going to work on your own. Again, the bottom row is definitely tougher than the top row. You should be able to do a lot of work on here, but you might want some like scratch paper for some of them if they're not already in slope intercept form. So I'll get you guys going on that, and then I'll upload this video for the people online. Yeah, go ahead. So feel free to move desks if you guys want to sit together.